less computing power than your smartphone has. People flew 500,000 miles round trip to the moon and back and survived, and then managed to bring all these amazing rocks back that have taught us about the entire solar system.
NASA quietly opened a box from the 1970s. Inside was a strange sample kept for decades. New tests say it does not match Earth, the moon, or known space rocks. The discovery shocked even veteran researchers across NASA. Why was it hidden for so long, and what happens when science unravels its mysteries? Stay with us as we explore Apollo's hidden cargo. The Apollo missions are often viewed as a positive and significant event in the history of mankind. Courageous astronauts embarked on a journey through space, successfully landing on the moon and safely returning home. The narrative presented to the public was one of optimism and simplicity. These missions were portrayed as a blend of bravery, scientific exploration, and new discoveries. However, beneath the surface of the publicized events and festivities, a different storyline emerged, characterized by discretion, mystery, and lingering uncertainties. The United States initiated the Apollo program, which was spearheaded by NASA in the 1960s, and it continued until the early 1970s. The primary objective of the program was to successfully transport human beings to the moon and return them safely to Earth. President John F. Kennedy transformed this aspiration into a commitment at the national level. Extensive efforts, including rigorous training and testing, were carried out over the years. The rockets utilized in the program increased in size, while the spacecraft became more durable. The astronauts underwent relentless training to condition both their physical and mental capabilities for the challenges that lay ahead. In 1969, Apollo 11 successfully landed on the moon, with Neil Armstrong and Buzz Aldrin making history by walking on the moon while Michael Collins remained in space. The world looked on in amazement at this incredible feat. Subsequent missions continued, with each one lasting longer and venturing further into space. By the time of Apollo 17, humans had explored more of the moon than ever before. In all, 12 individuals had the opportunity to walk on the lunar surface. The moon rocks and soil that were brought back were considered a valuable treasure by the public, serving as evidence of a successful mission. It was believed that studying these samples would provide insight into the formation of the moon and the early solar system. Small pieces of the rocks were showcased in museums as a way to educate the public. Children were taught in schools that these ancient stones were devoid of life, sculpted over time and through the vastness of space. The astronauts underwent rigorous training in order to gather these samples. They were taught techniques for scooping soil, chipping rocks, and drilling beneath the surface. Each action was crucial, as the moon lacked air, water, and any form of shielding. It was essential to maintain the cleanliness and integrity of the samples. The astronauts carefully secured them in sealed containers that were engineered to withstand the return trip to Earth. The mission appeared to be organized and orderly. However, the true situation was actually quite intricate. Different samples were handled differently. Upon arrival, certain samples were immediately categorized. These items were then relocated from public laboratories and stored in a secure area. A select few scientists were granted permission to handle them. Their access was closely monitored and restricted. Specific containers were utilized for particular samples. A few of them were sealed on the moon's surface and never came into contact with Earth's atmosphere. Following touchdown, other samples were preserved in specialized gases or frozen conditions. The intention of these measures was to maintain the samples in their original state. NASA aimed to prevent any potential contamination. However, this meticulous attention to detail also demonstrated a profound level of care. In the quiet confines of secure laboratories, researchers diligently conducted their work. These specially designed spaces were intended to maintain a sterile and regulated environment. Covering themselves from head to toe in protective gear, they were careful not to contaminate the samples in any way. Even the act of breathing was limited near the specimens. Every task adhered to stringent guidelines to ensure the integrity of the materials. The objective was to safeguard the specimens for further exploration in the future, anticipating advancements in technology and more advanced tools. During the testing process, unusual findings started to emerge. Several substances displayed formations not typically seen in Earth's scientific community. The internal compositions of these samples deviated from those of commonly recognized minerals. When subjected to high temperatures and pressure, specific specimens exhibited behaviors that were unanticipated. Their responses differed from those of comparable substances discovered on our planet. A notable finding was made when a sample returned from Apollo 17 exhibited a sulfur isotope ratio that was uncommon on Earth. This finding sparked debates among scientists regarding the Moon's origins, with some suggesting that it may be linked to its turbulent formation or to ancient events in its past. Despite the discussions, a definitive conclusion was not reached. For many years, numerous samples were stored away and inaccessible. NASA has recently started to unlock some of these samples. These were specimens that had been sealed during the Apollo era, maintaining their untouched and pristine state. Current scientists utilized advanced tools that were not available in the 1970s. Innovations in techniques enabled them to conduct in-depth analyses on minute quantities of the samples. Hundreds of kilograms of lunar material are stored in a highly secure vault at the Johnson Space Center. The vault is divided into two sections, with one holding immaculate samples in their original condition and the other containing samples that have already been examined or distributed. Accessing the pristine vault necessitates the presence of two individuals and the input of two different combinations. This precise protocol underscores the ongoing importance and delicacy of the lunar samples. The majority of the initial content remains secure, with some items being stored safely in New Mexico. Other pieces were utilized for study purposes or exhibits. Apollo 11 retrieved the least amount as safety was the top priority for the first mission. Subsequent missions gathered significantly more, particularly with the assistance of rovers that enabled astronauts to explore greater distances. Researchers are constantly gaining new insights from these rock samples. Analyzing them has been instrumental in establishing the ages of celestial bodies such as Mars and Mercury. The information gathered from these rocks has played a crucial role in developing theories about the evolution of the solar system. Novel discoveries are still unfolding even today. However, not all information was included in the public records. Several documents had pages that were missing and provided unclear summaries. Some tests were abruptly halted with no justification. Samples were discreetly transferred to more secure storage. These activities created discrepancies in the official narrative. So why was this discovery hidden this way? What were they trying to keep hidden? Let's dive in. When curiosity became a risk. The 1970s were a tumultuous period globally, with fear and authority influencing most important choices. The Cold War created rifts between countries, and outer space transitioned from a realm of exploration to one of power and influence. Each launch and discovery in space had significant political implications, reflecting national pride and global concerns. At that moment, the concept of acknowledging the existence of something unfamiliar was causing great concern. The public was anxious about any revelation of a mystery that could potentially cause widespread panic. Besides the existing fears of conflict, arms, and catastrophe, an unexplained phenomenon from outer space could potentially disrupt societal norms and beliefs. There was also concern among leaders about potential reactions from adversaries, as well as the public's response to the idea of science facing an insurmountable barrier. Due to the constant pressure, individuals often found solace in remaining silent rather than speaking truthfully. Inquiries were permitted, but there was a limit to how far one could inquire before it was deemed risky. In the midst of a tense environment, a specific specimen quietly garnered interest. Historical records uncovered that a certain Apollo sample distinguished itself among others. Gathered during a lunar expedition, this sample was managed by a select team. Upon its return to Earth, it was handled differently, deviating from the normal procedures of analysis and distribution. Early on, the sample was identified as peculiar. It was noted that it deviated from the expected norms upon initial examination. Questions were raised about its arrangement. The composition did not neatly fit into any established classifications. Instead of being openly discussed, there was a sense of caution surrounding it. The sample was segregated, restricted, and omitted from regular reports. It became a topic limited to specific discussions. A group of researchers observed the variation and started to raise inquiries discreetly. They pondered over the reason for the distinct behavior of this substance. They speculated if established lunar phenomena could provide an explanation. These conversations took place privately, away from public forums and formal publications. The discussions occurred in confidential dialogues amongst trustworthy peers. Within NASA, divisions began to emerge. While some scientists argued for a more thorough analysis of the sample, others were concerned about the potential consequences of delving too deeply into unknown territory. The directive from higher-ups was apparent. Concentrate on the aspects that could be rationalized and steer clear of anything that defied explanation. A small group of researchers found it challenging to acknowledge the situation. Their passion for acquiring knowledge and exploring new things had been a driving force in their lives. They viewed unanswered queries as chances for growth rather than obstacles. However, voicing their opinions resulted in negative outcomes. Progress in their careers stagnated, and obtaining funding for their studies became more difficult. Additionally, their involvement in prominent projects gradually diminished. Though no formal penalties were imposed, the implicit message was clear. As the years passed, the query slowly disappeared. The specimen was safely tucked away. Documentations became more concise and lacked depth. Society progressed, thinking that the moon had divulged all of its mysteries, and yet the story doesn't end there. Could it have been alive? Scientists examining unusual extraterrestrial samples started to ponder a silent and unsettling inquiry. This question, though not explicitly mentioned or documented, loomed ominously in the shadows. It was a basic but deeply disturbing query. Had it possessed life at some point? Certain characteristics of the material made a few scientists ponder about its potential biological origin, instead of it being just an ordinary rock. Upon closer inspection, they noticed organized patterns in parts of the material rather than random formations. These patterns seemed to be layered and structured, resembling the gradual growth process. Although this discovery did not confirm the presence of life, it prompted some researchers to take a second look. The addition of chemical indicators raised alarm. The reactions occurring within the samples suggested processes typically associated with living organisms. These reactions deviated from the normal behavior expected from inanimate substances. During experimentation, the samples exhibited behaviors that seemed dynamic rather than static. Their transformations, reactions, and changes puzzled the researchers observing them. During the testing, the reactions observed were quite concerning. The material appeared to react as if it had a mind of its own when subjected to specific conditions. These responses hinted at organic-like characteristics, despite the absence of any recognizable life form. Scientists proceeded cautiously, fully aware of the potential implications of such implications. During the same time frame, inquiries were also being made regarding Mars. In 1976, NASA's Viking landers made contact with the red planet's surface. Their objective involved conducting experiments aimed at detecting signs of life. Certain findings were confusing and posed challenges for explanation. Years later, an astrobiologist proposed the idea that Viking might have come across minuscule life forms residing within Martian rocks. Experts were split on the concept that these hypothetical life forms could have been delicate and resilient, potentially enduring in harsh environments for extended durations. The Viking experiments might have been too rigorous, leading to potential destruction of any existing life forms. The notion led to a disagreement among scientists, with some considering it feasible while others attributing the results solely to chemical reactions. The concept continued to linger despite attempts to dismiss it. If Earth can support life in harsh environments, then it is plausible for life to exist in other places as well. The issue at hand is not lack of evidence, but rather the lack of certainty. In the confidential memos, a new statement emerged that caused a significant shift in perspective. It implied that certain substances might possess some level of reactivity. This particular concept sparked fear among the scientists. The realization that a substance could potentially undergo unexpected changes or reactions challenged the conventional understanding of non-living substances. This revelation pushed the boundaries of scientific knowledge beyond what was currently accepted. The silent dread steadily expanded. Was it possible that humans unknowingly caused destruction? Could the specimens brought back or analyzed in the past have once belonged to a thriving ecosystem? These inquiries were not simple to address. They also bore a significant burden. No researcher desired to assert such a notion without having absolute certainty. Due to this, an official decision was never made public. Reports maintained a conservative tone. The language used was composed and gentle. Discoveries were presented in terms of chemical interactions, composition, and responses. References to life were skillfully avoided. The term alien remained absent, as alternative phrases were employed. Bizarre, astonishing, puzzling. By choosing these words, organizations were shielded from alarm and speculation. Additionally, this language safeguarded scientific integrity by avoiding premature assertions. But to understand the truth, we have to explain the Viking program. Stay with us. Viking on Mars. The Viking landers are remembered as one of the most hopeful moments in space exploration. These robotic spacecraft were sent to Mars with a bold dream. Scientists wanted to know if life could exist on the red planet. The missions were planned with great care and patience. Every detail was studied again and again. When Viking finally reached Mars in the 1970s, people all over the world waited with excitement. Many believed a great discovery was close. The Viking program began as part of an earlier NASA idea called the Voyager Mars program. That early plan aimed to do even more, but it was later reduced. This Voyager program was not the same as the famous Voyager spacecraft that traveled far beyond our solar system. Viking was chosen instead as the mission that would carefully study Mars up close. It became the best hope for answers. Viking 1 was launched in August 1975. Viking 2 followed 1 month later. Both spacecraft were carried into space by powerful Titan rockets. Their journey was long and slow. After traveling through space, Viking 1 reached Mars orbit in the middle of 1976. Viking 2 arrived soon after. The orbiters spent more than a month circling Mars. They sent back clear and detailed images. These pictures helped scientists choose safe places for landing. After careful planning, the landers separated from their orbiters. They entered the thin Martian atmosphere and slowly descended. Viking 1 landed gently on the surface in July 1976. Viking 2 followed in September. This moment was historic. For the first time, advanced science tools were working on another planet. The Viking mission had 3 main goals. The first goal was to take clear pictures of the Martian surface. The second goal was to study the planet's air and soil. The third and most important goal was to search for signs of life. Everything about Viking was built around this question. Each lander carried 4 experiments designed to look for life. One experiment searched for organic compounds in the soil. These compounds often contain carbon and are linked to living things. Another experiment tested for metabolism by adding nutrients to the soil and watching for changes. A third experiment looked for carbon fixation, which could suggest photosynthesis. The last experiment studied how gases changed when soil was tested. At first, scientists felt hopeful. Some experiments showed small changes in gas levels. These changes suggested something might be happening in the soil. The labeled release experiment showed results that looked like metabolism. The pyrolytic release experiment also produced signs that made researchers curious. These findings made some scientists wonder if life was present. Soon, confusion followed. The experiment that searched for organic compounds did not give clear results. At that time, scientists believed any organic material found came from Earth contamination. Later missions would prove that organic compounds do exist on Mars, but during the Viking mission, this idea was not accepted. Many researchers believe the gas exchange experiment was the most important. This test did not show strong signs of life. Because of this, the overall view began to change. Even though other experiments gave interesting hints, the negative result carried more weight. Slowly, most scientists agreed that Viking had not found life. This caused deep uncertainty. Some experiments suggested activity, while others suggested nothing at all. Scientists struggled to explain how both could be true. The results did not fit well with known ideas. Over time, excitement faded. The findings were explained as chemical reactions instead of biological ones. Reports focused on non-living causes. The idea of life was pushed aside, not because it was proven wrong, but because it could not be proven right. Years later, new discoveries added another layer to the mystery. In the early 2000s, NASA missions found perchlorate on Mars. This chemical can cause reactions when heated. Many scientists believed it explained the Viking results. This idea became widely accepted. The Viking mystery was considered solved. After that, attention moved away from life detection. Mars was studied for water, climate, and habitability instead. The planet was seen as a place that may have supported life long ago, but not anymore. Still, some scientists disagreed. A few researchers involved in Viking believed the data deserved another look. One scientist strongly believed the labeled release experiment had found life. This belief was later shared publicly and reopened debate. NASA did not send new life detection experiments for many years. Missions like Curiosity and Insight focused on geology and atmosphere. Curiosity detected methane spikes, which can come from living or non-living sources, but no direct life tests were done. Some researchers quietly noticed similarities between Viking results and strange samples stored since the 1970s. Chemical reactions looked alike. Some Mars soil features reminded them of unusual lunar samples. These thoughts stayed private. NASA eventually said Mars showed no life based on available evidence. Funding limits, public expectations, and caution all played a role. Announcing life without clear proof carried risks. Public statements were careful and calm. The search for life continued slowly. Some research paths were never followed again. Viking stopped working in the early 1980s, but its questions remain. Mars had already shown signs that did not fully make sense, and the answers never came from the red planet itself. So if the evidence was real and not from Earth, where in the vast darkness of space did it truly come from? Tracing the origin of the unexplainable. Upon discovering that a particular specimen exhibited abnormal characteristics compared to typical earthly substances, scientists were inevitably prompted to ponder its origins. The query of its non-earthly source was not posed casually. It held significant implications, obligations, and trepidation. Unraveling this mystery required venturing into uncharted scientific territory, traversing the realms of uncertainty and the unknown. The initial action taken was to eliminate all potential sources. Meteorites were the primary cause that came to mind. Space rocks have been colliding with our planet for eons. A significant number of these rocks originate from Mars or the asteroid belt. Researchers have a good understanding of their chemical makeup. However, when the peculiar sample was compared to existing meteorites, it did not match. Its structure was different, and its composition was unique. Furthermore, it displayed different characteristics during testing, leading to doubts about its meteorite origins. Afterwards, researchers revisited the theories surrounding the creation of the Moon. According to one hypothesis, the Moon came into existence following a colossal collision during the early stages of Earth's development. It is believed that a combination of material from Earth and another celestial body led to the formation of the Moon. The majority of lunar samples support this narrative by displaying chemical characteristics similar to those found in Earth rocks. However, there was one sample that deviated from the norm. Its internal composition did not align with the expected blending of materials, raising some concerns. The fact that this sample did not conform to established lunar formation processes made its presence on the Moon even more puzzling. The possibility of contamination was taken into account, including the chance of Earth material contaminating the sample. This hypothesis was investigated and ultimately rejected. The sample had been securely sealed and shielded from any potential contamination. Certain materials had not come into contact with Earth's atmosphere at all. Rigorous protocols were adhered to throughout the process, from gathering the sample to storing it. The risk of contamination was minimized, eliminating the likelihood of human error or accidental mixing. As conventional theories lost relevance, focus shifted towards external sources. Certain researchers started exploring the possibility of an interstellar source. This would indicate that the substance originated far outside our solar system. Such a substance would be exceptionally uncommon, requiring unique conditions not typically found on Earth or the Moon. If proven correct, it would imply that something traversed immense cosmic distances prior to reaching the Moon. Material from outer space would have distinct characteristics not found in substances created in the vicinity of our solar system. Its composition would demonstrate exposure to unique conditions, influenced by mysterious factors and periods of time. The discovery of such material would be remarkable and would prompt inquiries into its origin and why it had not been detected earlier. The existence of such material would disrupt the belief that space is void and far away. It would indicate that objects and even data have the ability to travel between star systems with more ease than previously thought. This concept alone was enough to disturb scientists. There was a potential discomfort that some pondered about whether the material was deliberately placed. This notion was seldom vocalized, hinting at intention rather than coincidence. If the item wasn't a result of natural elements, it could potentially be remnants of something man-made. Is it possible that the debris originated from a man-made structure or object rather than occurring naturally? Is it possible that this is proof of advanced technology, not of this world? This concept instilled fear in scientists the most. It transitioned from a discussion on geology to contemplating the existence of superior intelligence outside of human capabilities. Merely bringing up this question appeared risky. So if this discovery was world-shaking, why was it kept hidden? Let's find out. Why the truth was locked away. For numerous years, individuals pondered the reasons behind NASA's limited communication regarding specific findings. Records were kept confidential. Specimens were archived. Inquiries were skirted. This lack of transparency was not coincidental. It was influenced by apprehension, prudence, and the weighty burden of wisdom. Unraveling the reasons behind NASA's prolonged silence necessitates examining the historical context and the perceived threats leaders were concerned about. Public response was a major concern, as space findings have implications far beyond just science. These discoveries have the potential to challenge beliefs, sense of self, and significance. For numerous individuals, the concept of extraterrestrial life intertwines closely with religious beliefs. A mere revelation has the ability to disrupt firmly held convictions about the origin and meaning of existence. Authorities feared that the dissemination of such information might lead to perplexity, anxiety, or a crisis of faith. Politics also had an impact. In the time of the Cold War, each significant finding had political significance. Acknowledging an unfamiliar entity could be viewed as a sign of vulnerability. Adversarial countries could take advantage of doubt. The stability of the world relied on authority and trust. Politicians worried that alarming information could cause turmoil or confusion between nations. One worry was that a single declaration could immediately alter everything. The pace of scientific progress does not align with how quickly the public reacts. A finding that requires years of research may cause immediate alarm upon being revealed. NASA needed to assess if society was prepared to receive information that even science could not completely clarify. Beside the public's apprehension, there existed ambiguity in the scientific field. Scientists are taught to proceed with caution, drawing conclusions based on evidence, repeating experiments, and presenting clear findings. At times, the data posed questions without offering definitive solutions. Acknowledging uncertainty at such a significant level seemed perilous, risking the erosion of trust in science if the public perceived scientists as lacking comprehension of the world. There was a concern about making mistakes. Once a statement is made, it is difficult to retract. If NASA declared something remarkable and then discovered a more straightforward explanation, the consequences would already be irreversible. Professional images, status, and the trust of the public were on the line. In the field of science, being careful is often seen as a better option than making daring assertions. As a result of this, a plan began to take shape gradually. Categorize immediately. Elaborate afterwards. By following this method, there was room for contemplation and more research. Specimens were kept in protected storage. Information was shared with select audiences. The intention was not to conceal indefinitely, but to postpone disclosure until advancements in technology and knowledge were made. Including the anticipation of improved technology in the strategy was essential. Researchers were aware that upcoming tools would possess greater accuracy and sensitivity. Phenomena that were previously indiscernible could become comprehensible in the future. By safeguarding specimens, NASA allowed upcoming scientists to discover solutions without the urgency of instant public reaction. This approach shifted accountability to the future. The upcoming generations would possess greater expertise and understanding, growing up in a society accustomed to space discovery. Allowing them to make the decision seemed like a considerate decision rather than evading responsibility. Science has progressed gradually, leading to the development of new tools capable of studying minuscule details without causing harm to samples. The ability to now examine old materials in ways previously inconceivable in the 1970s has unlocked opportunities that were previously inaccessible. Contemporary researchers have started to re-examine antiquated specimens. What was previously considered peculiar yet ambiguous is now subject to in-depth investigation. Cutting-edge analytical techniques have enabled scientists to scrutinize structures, compositions, and behaviors with remarkable precision. As a result, these methodologies have minimized doubt and bolstered assurance. As research progressed, certain scientists started claiming that the evidence was more compelling than previously thought. The composition was not as closely aligned with Earth's as previously assumed. Conversations surrounding the possibility of extraterrestrial life became more earnest and contemplative. These were no longer considered outlandish notions, but rather cautious discussions supported by enhanced data. The timing of these ongoing conversations is significant. Current Mars missions are bringing back samples to Earth. These missions have been planned with insights gained from previous experiences. Each stage includes meticulous handling, stringent regulations, and cutting-edge testing. Scientists are optimistic that these samples will provide answers that were previously unattainable with Viking and Apollo missions. Exploration of outer space has been altered by the involvement of private entities. Government agencies are no longer the sole explorers of space, as new players with different perspectives and financial backing have joined the industry. As a result, a more diverse and innovative atmosphere has been created, encouraging the asking of daring questions and the discovery of surprising solutions. What do you think about the NASA sample? Let us know in the comments. If you enjoyed this video, like, share, and subscribe to this channel for more of these discovery videos. Before you go, watch the other videos on your screen.